Hey everybody, Mr. Gibson here. So for this assignment, this hook activity, you guys are really going to start to explore what atoms are made of, how they're made up, what different subatomic particles make up each and every atom in the universe, which I think is pretty cool. So first, I recommend that you watch this video, which if you're hearing me say that, you already are, so good job. And like I said, this assignment says we are going to introduce what atoms are made of, and we're going to use a gizmo simulation to do that, but this is not going to be as intensive as your normal gizmo assignments. Now, we will do a larger assignment with this gizmo later on in this part of the unit, but today is just kind of letting you play around with it, getting you introduced to it, letting you get used to the structure of the atom. Okay, so to begin, it says go to the Gizmo website, explorelearning.com. I've already got it pulled up, and you're going to launch this gizmo called Element Builder. Okay, this is what it looks like when you launch it. It's pretty cool. I love this thing. So here you've got protons, neutrons, and electrons. So those are the three what we call subatomic particles, or particles that are smaller than an atom, and they're what make up atoms, okay? So to add protons, you click this button here, and you can see them add to the simulation. To add neutrons, you do this, and you can see that both protons and neutrons, when you add them, go into the center of the atom. We call that the nucleus. Just like your cells have a nucleus, like we've talked about before, atoms have a nucleus. They have a dense center made up of protons and neutrons, the heaviest particles in the atom. Okay, and then you see here we have electrons, and when you add those, you can see those don't go inside of the nucleus. Rather, they orbit the nucleus, kind of like how planets orbit the sun or how the moon orbits the earth, okay? Some other things that are really useful to know, this will show you the element's name. So here I added 3 protons, so this is lithium. This will show you the element symbol. So lithium symbol on the periodic table is Li. And you can even click this to show the element notation. Now, what this will show you is 2 numbers. Actually, it'll show you 3 numbers. I'll show you the third one here in just a second. The top number here, see the number 6, is the total number of the protons plus the neutrons. Okay, we call that the mass number because they're heavy and they make up the mass of the atom. So the protons and the neutrons added together, that gives you the mass number. Now this number down here, the number 3, is the atomic number. And that tells you how many protons there are. So watch this. When I change this, you can see both the mass number and the atomic number change because the mass changes because I'm adding protons to the nucleus. The atomic number changes because I added protons. If I add neutrons, notice the atomic number on the bottom doesn't change. It's the protons that determine the atomic number. Now, watch this. As I add electrons, another number pops up. Or if I take away electrons, another number pops up. So protons and electrons are electrically charged. And when you have the same number of each, the positive protons cancel out the negative electrons, and there's no charge, like this. Okay, there's just nothing there. We call that being neutral. But in a lot of cases, that's not what's actually going on inside of an atom. In a lot of cases, the atom will have gained or lost electrons. Electrons can be taken or given away or gained. So, for example, if lithium here only has 2 electrons, then this number tells you the charge, the electric charge of the atom, which is a +1 in this case. Okay, this is the electron diagram. This shows you the symbol of the atom, and it shows you how many valence electrons that atom has. The valence electrons are simply the outermost electrons, okay? So you can see here, whoops, okay, let me go back. So you can see here that lithium has 3 total electrons, but only 1 on that outermost ring, and so it only has 1 valence electron. And then this shows you what group it's in on the periodic table, which is the column, and what period it's in, which is the horizontal row. So that's almost like playing like a game of Battleship or chess or something like that, where you have a grid. Think of the periodic table like that. So this is in group 1, so in column 1, and it's in the second row. So if you were to look at the periodic table, you would see lithium in the first column, and it's the second one down. Okay, so hopefully that's enough to get you guys started on how to use this simulation. Now, the actual assignment you're going to be filling out today is right here. It says open this with Kami. And so I won't open it with Kami because it will look the same and I don't want to waste time, but I'll show you what it looks like. So you're just going to answer some information about the particles of the atom, and then you're actually going to build different atoms. You're going to build all these different atoms. You're going to tell me how many protons are in them, how many neutrons, and how many electrons, okay? And then you're going to answer these questions. How many electrons are in a neutral atom of lithium? Remember, that's when the protons and electrons are the same. How many neutrons are in an atom of magnesium? When it has 25 as its mass number, and so on and so forth. And then you're actually going to use the drawing tool in Kami, and you're going to do your best to draw two different atoms. If I'm not going to grade you based on artistic ability, it's okay if they look kind of janky or if they look absolutely magnificent. But I'm not looking for like Leonardo da Vinci type drawings here. Just do the best you can with the drawing tool on Kami. The point is that you're getting to play around with this. You're getting to really get your hands dirty with how atoms are made up and what they look like. Okay, if you guys have any questions, if you're stuck on anything, feel free to email me. All right, guys, good luck.